when we talk about organic chemistry is the chemistry of carbon and hydrogen, or they said the chemistry of alkane. We call it a chemistry of alkane and its derivative. Can you hear me properly?
Yes, sir.
So the first thing, we have a lot of families in organic chemistry. Number one that we have alkane. We have alkane. Number two, we have what we call alkene, right? Number three, we have what we call, what do we have? Alkyne. Yes, we also have what we call a substituent. As I said, in our previous classes, we have what we call a substituent. What do I call it? Substituent. So the substituent is called alkyl group. What do I call it? Alkyl group. So when we said a substituent, what do a substituent mean? A substituent are chemical species. What do I call it? They are what? Chemical species with unpaired electron. You can put it down. They are chemical species with what? Unpaired electron. Now, when we are talking about this family, the family itself that we are talking about. So the alkane, they have the general formula alkane. They have the general formula, which is what? CnH2n plus 2. This is the general formula for alkane. They have the general formula of what? CnH2n plus what? Plus 2. That's the general formula for alkane, as we already know. So when we said alkane, so before we can say anything on organic chemistry, we need to know what are number one.
Sir, please, sir. Sir, can you please define that substituent?
So I said a substituent. A substituent are chemical species. They are chemical species with unpaired electron. What do I call it? They are what? Chemical species with what? Unpaired electron. And I gave you an example. I said the example of these chemical species, they are what? They are alkyl group. This is it, alkyl group. So we still have all others, other substituents, but we are still coming up on it. So let's just go about the alkane. Alkane has the general formula of what? CnH2n plus 2, right? Are we together? So now when we said it has the general formula of CnH2n plus 2, so we need to know, okay, what are number one of what of chemical compound? Number one, you need to understand this. Number one is we have mets. Number two, we have ets. Number three, we have prop. Number four, we have boots. Number five, we have what we called, what do we have? We have paint. Number six, we have what? What's number six?
Help.
Is it F or X?
Help.
Yeah, number seven, what do we have for number seven? We have X, right? Number eight, what do we have? We have oct. Number nine, what do we have? We have none. Number 10, what do we have?
Deck.
We have deck. Number 11, what do we have? We have dodecade. Dodeck. So we have dodeck. These are the things that we just need to. We have number 20, which is icosane. We have 30, tricosane, and so on and so forth. But we just need to limit ourselves at number 10 here, which is what? Deck. Now, any family of organic compound, we make use of the last three names. This is the name ending. So we just add this name ending to each hydrocarbon. For example, this met, when you add ANE, it becomes what? Methane. When you add ANE to this, it becomes what? Ethane. This one becomes propane. This one is what? Pentane. This one is what? Hexane. We have heptane. We have octane. We have nonane. We have decane, and so on and so forth. This is what we need to know about the organic chemistry. Now, it means that this for the methane, for this methane, can you see the board perfectly, please? Yes. For the methane, you know our N equals to 1. Don't forget that the general formula for our alkane family is CN H2N plus what? Plus 2. Now, when N equals to 1, just insert wherever N equals to 1. It becomes what? C1 H2 into bracket 1 plus what? Plus 2. Is that not so? Are we together?
Yes, sir.
Now, 2 times 1. 2 times 1 becomes what?
Plus
2.
2.
2. 2 plus 2.
4.
4.
That's where we have what? CH4 as number 1 of alkane, which is what? Methane. Are we together?
Yes, sir.
Yes, exactly. So this is what we have. For when n equals to 2, when our n equals to 2, we are going to have what? C2 H2 into brackets 2 plus what? Plus 2. 2 times 2.
4.
4 plus 2.
6.
6. We have what? C2H6. And C2H6 is what? Is ethane. Are we together?
Yes,
Khadija,
sir.
do you have any question? I see you raising up your hand. Okay, no question so far. Okay, let's go to number 3. Okay, Ajibade, what's your question?
Sir, you wrote 11 is dodecane instead of undecane.
Instead of what?
Undecane.
It is not on decane. It is dough in organic chemistry. It is, what is dough decay?
11. Dodecane is 11.
Yes, that's what
Undecane.
I wrote now.
Yes.
But you asked that it is on decay.
Yes, sir.
Where do you see your own? Where do you see it?
Sir, is what I know and what I saw too.
What is now dough?
12, sir.
12 is dough.
Yes, sir.
12 is dough. Okay. Maybe it's a mistake from me. Maybe it's something I've forgotten. Okay. There's no problem about that. So it is on decaying. I'm coming. Let me. On decaying. Okay, sorry. It is on decaying. Thank you very much for calling us up onto the mistake. So it is on decaying. So number 12 is dodecane. So if you want to know number 13, I think number 13 should be try decay.
Try decay.
Yes. Number 14, tetradecane. Number 15 is pentadecane, as we have. Number 16 will now be hexadecane, heptadecane, octadecane, nonadecane, before we reach 20. 20 is ecosane. So just let us just go and know that. So thank you for calling us to order. Jazakallah khairan. So, okay. So the second one is that ethane. And the next one is when n equals to 3. When n equals to 3, what do we have? We have C3H2 into bracket 3 plus 2, which is what? 2 times 3, which is 6 plus 2. That's what? C3H8. So now, when n equals to 4, will be C4H what? H10. When n equals to 5, it will be what? C5H12. C6 H what? H14, 67, H16, 68, H18, 69, H20. Right?
Yes.
Are we together? Before we reach C10, H22. These are what we have for alkane family. So C3H8, it is what? Propane. C4H10, it is what? Butane. C5H12 is what?
Pentane.
Pentane. C6H14.
Hexane.
C7H16. 68H18. That's octane, nonane, and decane. These are what we have for alkane family and so on and so forth. So now, to now proceed, so we know, we said the organic chemistry, we have different names. We are done with alkane family. We need to move to alkene family. And alkene family, we have the general formula for alkane. We have the general formula of what? CnH2n. This is the formula for alkene that we have, CnH2n. So when n equals to 1, we have C1H2 into bracket 1, which is C1 2 times 1. Are we together? We have CH2. But in organic chemistry, or what we call covalent bonding. So in covalent bonding, the methane, which is CH4, that is this carbon, is being surrounded by how many hydrogen? Which is 4 hydrogen, which is C. When you want to draw it, you have C, you have H. Okay, sorry. Can you hear me now?
It's cracking.
Okay. Can you not hear fully now? Or you is still cracking, as you said?
It's still cracking.
Maybe it is your network. Maybe you should
Maybe
rejoin.
your network.
Okay.
Log out and rejoin, please. Are we together?
Yes, sir.
Yes, sir.
So we have H, we have H here. It means that this carbon itself is surrounded by how many hydrogen? It's surrounded by 4
Oh, I do.
hydrogen. It's surrounded by 4 hydrogen. We know this through what we call covalent bonding. So now, all the bond in organic chemistry, it is now known that the bond that must surround a carbon must be how many? Must be 4. Must be how many? 4. The bond that must surround a carbon must be 4. Are we together?
Yes,
Are we together? So this is methane. The second one, which is ethane. Ethane. You know, ethane is what? C2H6. Let's now draw the ethane. We have how many carbon atoms? We have 2 carbon atoms, right? We have hydrogen. We have hydrogen. We have another hydrogen. We have hydrogen. We have hydrogen. We have another hydrogen. Now, don't forget that we said the bond that must surround the carbon was how many? Must be 4, right? Now, this carbon, this only carbon here, let's count the bond that surround it. If you want to show it, this is the bond that surround it, right? Which is 1, 2, 3, 4. Are we together?
Yes, sir.
Now, the bond that surround this carbon as well is also what? Is also 4. Are we together? So when you count the total numbers of hydrogen that is there, it is still remains 6. That is why we said ethane itself, we call it satisfactory hydrocarbon. What do I call it? Satisfactory hydrocarbon. Because it is being satisfied. Are we together? So now, if you draw another hydrocarbon, which is for alkane family, for example, propane. Propane is what? What is propane? Propane is what? C3H what? H8. We have how many carbon atoms? We have 3 carbon atoms, right? We have 1 hydrogen here. We have another hydrogen here. We have another hydrogen here. We have another hydrogen here. We have 1 hydrogen here. 1, another here. Are we together? When you count it, we have 1, 2, 3, 4, 5, 6, 7, 8. It is C3H8. When you check this carbon, the bond that surrounds this carbon itself is 1, 2, 3, 4. Are we together? The one that surrounds these as well is 1, 2, 3, 4. 1, 2, 3, 4. So it is complete. So the bond that must surround the carbon must what? Must be 4. Are we together? Are we together? Now, let's now go back to the alkene family, alkene itself. You know, we said alkene has the general formula of what? CnH2n. Are we together? Now, we said when n equals to 1, it is what? C1H2 into bracket 1, which is 2 times 1 is equals to 2, right? And don't forget, from what we have been told in chemistry, from the law in chemistry, that the bond that must surround the carbon must be how many? Must be 4. But now, here, we have CH2. When you have CH2, are we together? When you have CH2, when you draw it, how many hydrogen, how many bonds do we know does it surround this carbon itself?
3.
CH2.
2.
We have 2, right? And we said the bond that must surround the carbon must be how many? 4. Right?
Yes, sir.
That's why this does not exist in chemistry. So that's why number 1 for alkene does not exist in chemistry, because the bond that surrounds this carbon itself is just 2. And the bond that must surround the carbon must be how many? Must be 4. Are we together? So that's why number 1 in alkene does not what? Exist. Now, let's now move down. Okay? Are we done with the written, or we should continue?
Continue.
So, Okay. Let's go to number 2. Number 2 for alkane family. We have N equals to 2. Well, we now have C2, H2 into brackets 2, right? 2 times 2. What do we have for 2 times 2? 4. We have what?
4.
C2, H4. Now, this is where we are going. We write it. Now, it now depends on the family itself. In alkene has carbon to carbon double bond. What do we call it? Carbon to carbon double
Bond.
together. Are we together? So now in organic chemistry, there are 2 special types of bond. 2 types of bond. Number 1, we have what we call sigma bond. What do I call it? Sigma bond. What number 2 is pi bond. Sigma bond is just like this. While pi bond is just your pi. We have the 2 types of bond in organic chemistry. We have what? We have the sigma bond and we have the what? We have the pi bond. Now, when we talk about the sigma bond are bond that cannot be broken. A bond that cannot be what? That cannot be broken. That is, in organic chemistry, you cannot separate that. But pi bond can be broken. Can be what? Can be broken. That's the difference between the 2 bonds. Are we together?
Yes,
okay, we can put it down. So let's put it down. So now, don't forget that here we have C2H4. How do we now go about it? So we now said in alkene family, they have what? Carbon to carbon what? Double bond. That is the bond between carbon to carbon is what? Is double bond. So now, the first one here is what we call what? Sigma bond. It is the same thing, that sigma that of the alkene family. While the second one is what? Pi bond. Are we together? This can be removed. This pi bond can be what? Can be removed. Are we together?
Yes, sir.
Yeah. What of others? You are not talking, oh.
Yes, sir.
Okay. So now, if you now want to write it, we have C double bond C. We have C2H4. That's that we have 2 hydrogen here. We also have 2 hydrogen here. We also have 2 hydrogen at this side. Are we together? So now, don't forget that. Do you still remember the law? The law says that the bond that must surround a what? A carbon must be how many? 4. When you count this one, 1, 2, 3, 4. That's number 1. This one as well. It is 1, 2, 3, 4. Are we together?
Yes, sir.
So
Yes,
now,
sir.
this is what we need to understand. So that is why in the properties of alkane, you know, I said we have 1 sigma bond. And note, the sigma bond that we said cannot be broken. It is just 1. We can only have 1 sigma bond in organic, in what? In a compound. Why pi bond 1 or what? Or 2? It is not more than 2. Sigma bonds are not more than 1. It's not more than 1, sorry. Why pi bond? They are not more than 2. That's the difference between them. Are we together? So now, this is pi bond, as we said. Why this is what? Sigma bond. And in alkane family, can undergo what we call additional reaction. What do I call it? Additional reaction. That means that there is something can be added to it to remove this pi bond. Are we together? Are we together?
Yes, sir.
Yes, sir.
Now, how do we now know this? We can know this through, we can know this through the differences between alkene and alkane. Alkane and what? And alkane.
Okay.
Number 2 of alkane. What is number 2 of alkane family?
Prop.
C2,
C2 what? H6, right?
H4,
Alkane family. C2, H6 for alkane,
H6.
right? This is
Yes, sir.
ethane. Why for alkane family we have C2H4, right? This is ethene.
14.
Are we together?
Yes, sir.
Who can tell me the differences between alkene and between ethane and ethene?
The number of hydrogen atoms.
The numbers of hydrogen atoms. How many hydrogen atoms are lost? In
2.
2. We have the numbers of hydrogen that are in ethene is what? Is 2 hydrogen atoms. Now, you will now need to know that for ethene, we have double bond, right?
Yes,
Yes.
sir.
Sorry, double bond.
This is what we have. Exactly. So this pi bond is the one taking these 2 hydrogen inside.
Hydrogen.
Are we together? Now,
Yes.
in this case, they now said for one particular bond, in a bond, we must have 2 electrons. You must have a what? 2
Small
electrons.
electron.
That's why they said 2 electrons makes a bond. Are we together? So now, before ethene can become ethane, we must add how many hydrogen atoms? 2 hydrogen atoms. These 2
Hydrogen.
hydrogen atoms, you know what? We now break down this pi bond to remain sigma bond. Are we together?
Yes, sir.
Now, that shows that between alkene and alkane, that shows that there is what? 2 hydrogen atoms, which is what? Which has been lost. Are we together? So
Yes,
that's what
sir.
we need to know. So let me just. So for alkane that we are saying, that's number 2. Number 3, n equals to 3. It will be what? C3H what? H2 into
C3,
bracket 3.
H3,
That's C3.
H9.
No, 2 times 3.
H6.
Okay, 6. 6.
6. That's C3H6. The next one, when n equals to 4, what are we going to have? We have C4H2 into bracket 4.
H.
So
H8.
C4H8. The next one will now be C5H what?
H10.
H10. And
H10.
so on and so forth. Are we together?
Yes, sir.
So now you should be able to complete the rest, right?
Yes, sir.
Now,
Yes, sir.
let's now go to the so-called homologous series. Homologous series. What do you understand by homologous series?
Grouping.
What do you understand by homologous series?
Homologous series.
They are a group of organic compounds that have the same functional group.
They are group of
Homologous
organic.
series.
family of organic compounds with similar structures and property.
Okay, fine. Ali Daya, you say something. I can't
Yes,
hear
I
you.
said it's a group of organic compounds with the same functional group.
With the same functional group. Who else
Yes.
again? That's good.
Mm.
That's good. Okay, without wasting much of our time, homologous series. Homologous series is a family of organic compound which follows a structural pattern in which two consecutive member, in which what? You need to
Two
note that.
consecutive.
Two consecutive member, in which two consecutive member are differ in molecular formula. Are differ in what? Molecular formula by CH2 and molar mass. Molar mass by 14 units. Molar mass by what?
14.
14 units. This is what we call homologous series. So homologous series is what? Is a family of organic compound which follows a structural pattern in which two consecutive member. Okay. Homologous series is a family of organic compound that follows a structural pattern. It follows a structural pattern. Two consecutive member in which two consecutive member
that follow
a structural pattern. That follows a structural pattern in which two consecutive members are differ in molecular formula by CH2. Are differ in molecular formula by CH2. Molecular formula by CH2 and molar mass by 14 units. That's what we call what? Homologous series. So homologous series is a family of organic compound which follows a structural pattern in which two consecutive are in molecular formula by CH2 and molar mass by 14 units. So that's what we call homologous series. Now, how do you
So
explain
please
this?
can you come again?
Homologous series is a family of organic compound that follows a structural pattern in which two consecutive members are differ in molecular formula by CH2 and molar mass by 14 units. That's what we call the homologous series. That's homologous series. So now, for example, alkane family, alkane. The first member of alkane is CH4, right? The second member is what? C2, H what? H6. The third member is what? C3. Let's talk now. H8. The next member is what?
C4.
C4, H10, right? The next member is what? C5, H what? H12. Now, let's now go back to homologous series. What homologous series is saying? Homologous series says that is the family of organic compound which follows a structural pattern. This is the pattern in which two consecutive members, these are two consecutive members, right? Are differ in molecular formula by CH2. Molecular formula by what? By CH2. And molar mass by what? By 14 units. Let's now go about it. Now, when you check this, This is number 2. This is number 1. This is C2 and this is C. Abi, when you remove C from C2, what will it remain?
2.
1C from 2C. It remains what?
1C.
1C, right? Now, we have H6 here, right? And we have H4 here. When you remove H4 from H6, what will it remain?
H2.
H2. So now, what homologous series is saying is that these two consecutive members are differ in molecular formula by what? By CH2. When you remove this from this, what do we get? We have CH2 and molar mass by 14 units. And molar mass by what? 14 units. We need to calculate the molar mass of CH2. What's the molar mass of carbon? What's the mass number of carbon? 12. We have, sorry. We have carbon to be what? 12. And how many atoms of hydrogen do we have? We have 2 atoms of hydrogen. And what's the mass number of, what's the molar mass of hydrogen?
1.
1. That's 2 into bracket 1. 2 times 1, that's 2 plus 12. What do we get? We get what?
14.
14. That is what homologous series is saying. That in which 2 consecutive members are differ in molecular formula by what? By CH2 and molar mass by what? By 14 units.
14
Are we
units.
together?
Yes, sir.
Yes.
Now, even if you check this one as well, these two consecutive members, C3 and C2, when you remove them, what do you get at last? You still get CH2. Are we together? H8 minus H6. What do you get? You get H2. C3 minus C2. You get C as well. Are we together? So it's still the same thing. The 2 consecutive members are differ in molecular formula by CH2 and molar mass by what? By 14 units. Are we together?
Yes, sir.
Following. Any questions so far? There's no question. Okay. Now, likewise, alkene family. Alkene. Alkene family. The first member of alkene is 18, right?
Yes.
Which is what? What's the formula? What happened? Are we fasting today?
Yes, sir.
Yes.
Okay, sorry. Okay.
Yeah, we are okay.
Now, the first member is 18, right? 18. And 18 is what? C2H what? H4, right? The next member is C3H6. The next one is C4H8. C5H what? H10. So what you just need to be adding to this is CH2. When you add CH2 to it, you still get the same thing. What will now be the next member? The next member will be what? What will be the next member? C7, C6H12, right? The next member will be 6, 7, H what? H14, and so on and so forth. All these members, all these families, they follow what we call homologous series. The 2 consecutive members are differ in molecular formula by what? By CH2 and molar mass by what? By 14 units. Are we together?
Yes, sir.
Is that clear?
Yes, sir.
So now, where we need to go now is we need to move to alkyne. Alkyne. So alkyne. Alkyne. So alkyne family, we need to put the name ending. Alkyne cannot also start from number 1. It will start from number what? Number 2. And number 2, the general formula for alkyne is CnH2. H2N minus 2. This is the general formula for alkyne. Cn H2N minus what? Minus 2. When n equals to 2, you have what? C2 H2 into bracket 2 minus 2. 2 times 2.
4.
4 minus 2.
2.
We have what? C2 H2. How do we go about it? C2 H2. Definitely for this one, we are going to have one hydrogen. Why this one also, we are going to have one hydrogen, right? So, but in alkyne family, another one bond is being added, making it what? 3 bond. Making it what? 3 bond. Are we together? Now, in this case, let me ask you a question. How many sigma bond do we have in this compound?
Wow.
How many pi bond do we have?
2.
2 pi bond. We have 1 sigma bond and what? And 2 pi bond. And don't forget, from this alkyne to alkane, how many hydrogen has been lost from alkane to alkyne? Who can tell us?
4.
4 hydrogen, Abby.
Yes, sir.
And don't forget that we said 2 electrons make a bond, right?
Yes.
2 electrons make a bond. How many bond do we add to sigma bond in alkyne?
1.
From alkane to alkyne, how many bond do we add to this sigma bond? We add 2, right?
2, yes.
Now, for these 2, how many electrons do we have for these 2 bond?
How many?
And don't forget that we said 2 electrons make a bond, right? And we have 2 bond here. How many electrons are we going to have altogether?
6.
Okay.
5.
For this bond, you know we add 2 pi bond to it, right? To the sigma bond. And for each bond, we have 2 electrons. For each bond, we have 2 electrons, right?
Yes.
Are we together?
Yes, sir.
Yes, sir.
Okay. Now, for these 2 bond, you know, we have 4 electrons inside, right?
Yes, sir.
That shows that hydrogen that is being lost from alkane to alkyne, it is due to what? Due to the addition of this pi bond. Are we together?
Yes.
So now, for
If
this
it's not
now,
clear,
okay,
what you just explained is not clear.
let me re-explain. For alkyne, we have these, right? We have hydrogen, we have 1 hydrogen, which is C2H2, right? This is what we have, C2H2. Now, and we said the bond that must surround the carbon must be how many? Must be 4,
Must be
right?
4. Yes.
This carbon itself, it is being surrounded by how many bonds? 1, 2, 3, 4, right? Complete. This one as well, it is surrounded by 4 bonds. Are we together?
Yes.
Now, we now said from alkane to alkyne, how many hydrogen do we lose now? Someone said it is 4 hydrogen, right?
Yes.
Is that not so?
Yes, sir.
Now, what now takes that 4 hydrogen? It is these 2 pi bond. These 2 what? Pi bond. And don't forget that we said pi bond are bond that can be broken. Okay, Ajayi, what's your question? Do you have any question?
Yes, sir. When you
Okay.
are counting that bond, you said 1, 2, 3, 4, but I don't understand how you count it and it gives us 4.
Okay. This is what we have for the second member of alkyne, right? Which is what? Which is ethyne. Is that also ethyne? We now said the bond that must surround the carbon. So the bond that must surround the carbon, we said it must be 4, right? Now this is one carbon. This is one carbon. Now this bond is attached to this carbon, right? This hydrogen bond is attached to this carbon. Can you see it perfectly? That's one. Abby, this bond, this 3 bond is attached to this carbon as well. Are we together?
Yes, sir.
This is when you now want to count it. If you draw it like this, that shows that this 3 bond is attached to this carbon, right? And this 1 bond is also attached to this carbon, making it what? Making it 4. Are we together? 1, 2, 3, 4. Now this carbon as well. Here we have 1, 2, 3, 4. Are we together?
Yes, sir.
So that shows that these 2 carbon, they are sharing this what? These 3 bond. Are we together? So that's why we said the bond that must surround the carbon must be how many? Must be 4. Are we okay with that?
Yes, sir.
Now in this case, we have 1 sigma bond and we have 2 pi bond. Are we together? So is that clear?
Yes,
Okay.
sir.
Let's go to the second member. The second member, the third member, sorry. And when n equals to 3. When n equals to 3, we are going to have what? C3 H2 into bracket 3, right? Minus 2. 2 times 3. 6 minus 2. What do we have?
4.
We have C3 H4.
H2.
How do we go about it? Yeah, let's draw it. How do we go about it? Yeah, let's talk.
C.
C,
Triple
C,
bond.
Double
C,
bond.
C. Where are we going to put the triple bond?
Anyway.
Here. Let's talk, please.
No, the last one.
The last one here.
Yes.
Why can't it be here?
I think we are starting the counting from the left side.
Yeah.
They can start it.
Anywhere.
Okay, we can start anywhere. So either we can put it here or here. It does not determine. Are we together? So my brother said we can because we are starting from the left. No. If your double bond or triple bond starts from that left side, that's when you are, if you want to do the IUPAC nomenclature, the naming is that you are starting from that side. Are we together? Even if the triple bond is here as well, you are starting your counting from this side as well. Are we together? It can be placed in either at the right side or at the left side. Are we together? Now, this carbon, oh yeah, let's go with it. This carbon, how many bonds do we have for this carbon? Surround this carbon. How many bonds do we have for this carbon?
1.
1. And the bond that must surround the carbon must be how many?
4.
4.
4. How many hydrogen are we going to have for this?
4.
4.
No. You have 1 bond, right? Surrounding this
Yes.
carbon. So we need
Me.
3 bonds to
1.
surround this carbon initially. 1, 2, 3. Are we together?
Yes, sir.
Yes.
Let's go to this second carbon. The bond that surrounds this carbon itself is how many?
4.
4.
4, right? Do we need to add any bond to it?
No.
No. Okay, that's fine.
No.
What of this?
Yes.
Yes, we need to add.
3 bond.
Yes. Yes.
3 bond,
1.
right? It remains
Yes.
1 bond, Abby.
Yes, sir.
We need to add 1 hydrogen here. When you count the total numbers of hydrogen that is here, 1, 2, 3, 4, making 4, right? So that's why we have
Yes.
C3H4. Are we together?
Yes, sir.
Are we together?
Yes.
Yes, sir.
So that's why the name for this compound. That's why the name is what? What's the name? What's the name?
1-8.
Propene.
Homologous series.
Propine. We have propine. So because it is 3, we have what? We have propine. Are we together?
Yes, sir.
So any questions so far? Do you have any question? Or am I too fast?
I don't think.
Okay, sorry. Let me rewrite it.
Stop.
Are we done?
Yes. Sir.
Okay. Any question?
Now why don't you start a time?
Why can't I?
Start from a fine.
Why can't I start from etine? We've written it already. We've written it before. Etine that we said we have C2H2. And we said we have this. This is where we start from. So, and we said when we have this, it is this, the bond that surrounds this carbon is 4, while this that surrounds this is also what? Also 4. And we said it is what? Etine. So, I told you why we cannot start from methyne before. It is from that of the what? It's alkene compound. Are we together? So, that's how it is. Any questions so far? Any question?
Yes, sir.
No question, right? So if etine is C3H4, if it follows homologous series, what will be, okay, if propine is C3H4, if we follow homologous series, what will be next one, which is butane?
C4H6.
H6. The next one will be what?
C4.
C5H8.
C5H8. The next one will be C6H what? H10. The next one will be 6, 7, C7, H what? H12, and so on and so forth. Now, let's go to the substituent. The substituent. The substituent, as we said we have alkyl group. Alkyl what? Alkyl group for the substituent. And for alkyl group, the alkyl group has the general formula of what? CnH2n plus 1. Alkyl group. They have what? The general formula of what? CnH2n plus 1. Are we together? Now, we said the substituent. When we are defining the substituent, we said the substituent, they are chemical species with what? With unpaired electron. Why do we call them substituent? why we call them substituent is that they cannot stand on their own, like those of alkane, like those of alkane, like those of what? Alkyne. They cannot, this alkyl group cannot they cannot stand on their own. They merely attach to carbon. They merely what? Attach to what? Attach to carbon. That's why we call them what? Substituent. And they start from number 1 when n equals to 1. So we just need the last two names for them. Don't forget that number 1 in organic chemistry is met, right? Why number 2 is what?
F.
F. Number 3 is what? Probe.
Probe.
Number 4, boot, and so on and so forth, right? Are we together? So now, for this, if n should equals to 1, if n equals to 1, using this formula, what do we have? We have C1, right? H2 into bracket 1, right? Plus 1. 2 times 1.
2.
Plus 1. 3. We have what? CH3. And this CH3 is what? It's called methyl. What do I call it?
Methyl.
Methyl. So you call it methyl. Methyl. Some people call it methyl. They call it what? Methyl. So when your n equals to 2, what do we have? We have C2, H2 into bracket 2 plus 1. 2 times 2, 4, right? 4 plus 1, 5, right? What do we have now? What will now be our formula? C2, H5, right? The name for this, number 2, it is called ethyl. Ethyl.
Ethyl.
Yes. Why the next one? Hey, it's your network, oh my brother. Log in and log out and relog in. Sorry.
Is it a tire? Tire.
I can't hear you. What do you say?
A towel. Ethyl.
Ethyl. You said ethyl, right? Hey, I can't hear you. I mean that.
She's asking for
He
the
said-
pronunciation. She said, is it ethyl or ethyl?
Is it you? It is ethyl or ethyl.
Yeah.
Some people call it ethyl. Why some people call it what? Ethyl. Are we together? So, but
Yes,
the most common thing that we do call it here in Nigeria, we call it what? Ethyl. When n equals to 3, when n equals to 3, what do we have? We have what? C3, H2 into bracket 3 plus 1. Are we together? So it is now what? C3, H2 times 3, 6 plus 1, 7. C3, H7. You will see that this also follows what we call homologous series, right? What will be this name? The name for this will be what? Propyl or propyl. Yes, anyhow. So the next one will be what? C4, H9. The next one will be what? C5, H what? H11. What is the name for this? Number 4.
Butyl.
Butyl. What's this?
Ethyl.
Number 5. Number 5.
Pentyl.
Pentyl. Yes. Anyhow, so and so on and so forth. This is what we have. So for this alkyl group, we call them substituents. We also have other substituents that we need to know. Other substituents that we do find in organic chemistry. They are allo group. What do I call it?
Allo
Group.
Allo group. They are halogen family. They are halogen family. What are the halogen family? They are group 7 elements in the what? In the periodic table, right?
Yeah.
So the allo group, what are those allo group? We have the fluorine, we have the chlorine, we have the
Bromine,
bromine, we have the iodine, we have the astatine. So for the allo group, this one, this fluorine, we call it in organic chemistry. When we found them as a substituent, we call them fluoro. What do I call it? Fluoro. Why this chlorine is called chloro? Why this bromine is called what? Bromo. Why this one iodine is called what? What do we call iodine?
iodo.
I can't hear you. We call it iodo. Why the astatine is called what? Astato. So these are the allo group that we found in organic chemistry. You soon know it when we reach the so-called IUPAC nomenclature. Are we together?
Yes, sir.
Yes, sir.
Any questions so far? Do you have any question?
So
What's your question? So what's your question? What's your question? So this is we said they are substituent, right? So those are we have the substituent like alkyl group. We also have the what? We have the allo group. We also have so many substituents, but the most common one in organic chemistry is the allo group and that of the what? That of the alkyl group. Are we together? Are we following?
Yes, sir.
Okay. So on that, after that, another functional group that we have as in organic chemistry or as organic compounds is what we said when we are doing acid, base, and salt. We have the so-called alkanol, right? We have alkana. The alkana. Who can tell me another name for alkana?
alcohol.
Alkana. I just said alkanol. Alkanol, another name for alkanol is alcohol. Thank you very much. But for alkana,
Aldehyde.
aldehyde. Aldehyde. We have alkanone. What do we call alkanone?
Anode.
We call it ketones. So that's why in advanced chemistry, when they are defining carbohydrates, they said carbohydrate is polyhydroxyaldehyde and polyhydroxyketone. What do I call it? Carbohydrate is called what? Hydroxyaldehyde and polyhydroxy what? Polyhydroxyketone. Are we together? So that's the definition of carbohydrate. So because it comprises of what? The ketones and that of the what? Aldehyde, which is the alkana. Are we following? Are we together? Okay, thank you very much. So now, all these, if we are to talk about this thing, we also have alkanoids. We also have what? Alkanoids. So we have a lot of compound So which we are going to be taking it one after the other. So as we said, the alkanol that we said is also known as alcohol. Why alkanol is known as what? Aldehyde. Why alkanol is known as what? Ketone. So they have their functional group. For alkanol, the functional group of alkanol is OH, right? Why that of the alkanol? Who can tell me the alkanol? The alkanol is CHO. Why the alkanol is what? CO. So we are still coming back again.
COOH.
Yes.
Wait. Wait.
So now, before we come back to alkanol, we will simply look at types of organic compound. Types of organic compound. Organic compound. We have the types of organic compound in chemistry that we need to know. Number one is aliphatic hydrocarbon. What do I call it? Aliphatic hydrocarbon. I think we are familiar with that, right? Yes, thank you very much for that. We have aliphatic. Who can still remind us? Others.
Aromatic.
Is it aromatic?
Aromatic.
Aromatic. What
Yes.
next again?
Eh?
What do you have
Oh
again?
my God. Aliphatic, aromatic, and what to
We have aliphatic hydrocarbon. Number two, we have alicyclic. What do I call it? Alicyclic hydrocarbon. Alicyclic hydrocarbon. Number three, we have aromatic. Aromatic hydrocarbon. Hydrocarbon. And the last one, who can remind us the last one? We have arenes. What do I call it? Arenes. Let's quickly write it down before we proceed with the with it. So we have the types of hydrocarbon in organic chemistry, all types of organic compound. So we have the aliphatic. So all these things, we call them the arrangement. What do I call it? Arrangement of carbon atoms. It is the what? Arrangement of carbon atoms. How do carbon atoms, how do they arrange them? Is it either straight or branch? Is it either in forms of rings? Is it either in form of aromatic or in form of what? Arenes. Now, there are some questions. We've written it right. Yes. Yes. There are some questions that do come that they are going to ask you now regarding alkane, alkene, and alkyne. So there is this question that they do ask. Under organic compound, we also have two subtypes that you guys are familiar. Number one is And number two,
Yes, sir.
I'm very sorry about the network. So there is these two types of compound that we do have.
No.
Sorry, I'm very sorry. I'm coming. So we have two types of compound, like they do ask the question that you need to know: the saturated compound and unsaturated compound. Now, what we mean by saturated, when you said the word saturated, saturated means it has reached a point whereby we cannot add, it cannot undergo what we call additional reaction. What do I call it? Additional reaction. So for in this case, you know, for alkane family, you know, the first member, which is CH4, methane, right? We draw it as this. It has 4 hydrogen atoms, right?
Sir, can you divine the saturated, please?
So when I said saturated, off your mic, please. So when we said saturated compound, we said saturated compound are the compound that are what? That are what? Completely filled. It does not undergo any additional reaction. Are we together? It does not undergo any additional reaction. But unsaturated compound, it's usually undergone additional reaction. Are we together?
Yes, sir.
So that's what we call what? Hydrocarbon. So now, for example, the alkane family, which is CH4, you know, we said the bond that must surround the carbon must what? Must be 4. Right? So in this case,
Alkane is saturated.
yes, alkane, they are saturated because it does not undergo addition, because it is filled.
Yes.
So it does not undergo what? Additional reaction. So that's why we said alkane. All alkane member, they are what? Saturated compound. Are we together? Now,
Yes.
what are unsaturated compound? Unsaturated compound, for example, ethene. Let's use ethene as an example. Ethene is what? C2H what? H4. Right? Ethene is what? C2H4. So we have one H here. We have another H here. We have another H here. We have another H here. Are we together? So this is double bond. And this double bond comprises of what? Both sigma bond and what? And pi bond. You know, in this case, we have one sigma bond and we have one pi bond, right? So in this case, we said, I can't hear you, please. Are you talking to us? Okay, maybe it's your network. To this call, you can mute your mic, please. Okay, thank you very much for that. So If you cannot see, you can log out and relog in back, please. So in this case, we have a sigma, one sigma bond and one pi bond, and we said pi bond can be broken, right? In this case, this can also go back, this 18 can also go back to what? Ethane, by what? By addition of what? To hydrogen. That's why in this case, if you have any compound in this case, we call it unsaturated. We call it what? Unsaturated. Are we together?
Yes, sir.
Okay, that's fine. We have these 4 types of what? Organic compound or organic chemistry. So, which are the hydrocarbon. We have aliphatic hydrocarbon, we have alicyclic hydrocarbon, we have aromatic hydrocarbon, we also have arenes. So when we say aliphatic hydrocarbon is just the arrangement of hydrocarbon, either in a straight chain or branch, either in a what? Straight chain or what? Or branch. So they can either form in a straight chain or branch chain. For example, this is a straight chain. When you have hydrogen, you have hydrogen here, you have hydrogen, you have hydrogen, you have hydrogen, you have hydrogen here, you have hydrogen here, you have hydrogen. So when we have it like this, it's a what? It's a straight chain. But when you have something like this, when you have something like this, when we have something like this, so when we have something like this, so we have another CH3 here. So it can be either named like this, which is branch. It has a branch. This is what we call a substituent. So it can either name straight like this. So it's either straight chain or branch chain. So now in this case, this that we are saying is a branch chain hydrocarbon. Is an example of aliphatic. Aliphatic can either be alkane, can either be alkane, can either be alkyne, can either be anything. Either it should be in straight chain or what? Or branch chain. That's what aliphatic is talking about. Are we following, please? So
Yes, sir.
now, the second one is alicyclic. When we have alicyclic compound, they are what? They are hydrocarbon that are formed in rings. In what? Rings. So that is we form them in rings. That's why we call them. Please help us to mute your mic. So we found them in rings.
Benzene.
It's not benzene. So, and this benzene is also found in rings. But when we say alicyclic is either in form of alkane, or alkyne. Benzene is another thing entirely. Do you understand? So, example is this: when you have triangle. So, alicyclic, they start from carbon number 3. Carbon number what? Carbon number 3.
Number 3.
So it cannot start with 2 because their rings must be closed. Their ring must be what? Must be end closed. Are we together? So these are closed. They are closed. So that's why we have it as what? Triangle. When you have triangle like this, now let's now put the numbers of hydrogen here. We have one. How many bonds surrounding this carbon only? Who can tell us?
2.
2. How many hydrogen will it remain to make it complete?
2 hydrogen.
What of this? This carbon, 2. We have 1 hydrogen. We also have another hydrogen. What of this as well? 1 hydrogen, 1 hydrogen. But you can't then. The bond that surrounds this carbon is 1, 2, 3, 4. Surround this carbon 1, 2, 3, 4. 1, 2, 3, 4 complete. Are we together? In this case, this one is what? C3H what?
6.
H6. We have C3H6. The name of this compound, because it is alicyclic, any alicyclic must start with cyclo. Must start with what? Cyclo. Because it is alicyclic. But it is carbon to carbon single bond. It belongs to alkane family. It belongs to what? Alkane family. If it is carbon to carbon double bond, it belongs to what?
Sir, it's not clear.
Okay. Someone said I can't see the screen. You can log out and re-log in, please. So now, for alkane family, you know alkane family is carbon to carbon single bond, right? Alkene, carbon to carbon double bond. Alkyne, carbon to carbon triple bond, right?
Yes, sir.
Now, this carbon to this carbon, it is what? Single bond, right? This carbon to carbon
It is
is another
single.
single bond. That's why we said it belongs to alkane family.
Okay.
But it is cyclo compound, alicyclic. Are we together? It is cyclo compound, which is what? Alicyclic. Are we together?
Yes, sir.
Yes, sir.
In this case, this is carbon number 3. And carbon number 3, when we have carbon number 3, it is prop, right?
Yes, sir.
Yes, sir.
Right?
Yes, sir.
And we said whenever you want to name alicyclic, you start with cyclo. You start with what? Cyclo. And since it is carbon number 3, it is prop, right? And we said it is carbon to carbon single bond. We must have A and E, which is propane, right? So fine. And it is, so far it is cyclic. And we said it's going to start with cyclo. This one is now what?
Propane.
Propane. This is the name of this compound. Cyclo what? Propane. Are we following?
So I
Are we
have a
together?
question.
I can't hear you, please.
So I have a question.
What's the question? What's the question?
So maybe I didn't follow or I don't understand. Like, see, Like the C3H6, is it not supposed to be you said it is propane,
No, I
but
just
in
said I
normal.
did not said it is propane.
Okay, sir. I don't
Now,
understand that side.
okay, we're actually talking about alicyclic.
Yes, sir.
We said alicyclic are alicyclic hydrocarbon. They are what? They are compound or hydrocarbon that are found or that are formed, or that is, they are in rings. They are in what? They are in rings. Are we together? And their rings are end closed. They are what? End closed. And I said for alicyclic hydrocarbon, they start from carbon number 3. They start from what? Carbon number 3. And the example that we gave here is this example here that we have. We have carbon, 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 which is closed. It is in ring like this. They are closed. There is no open space here. Are we together? Compared to this, these are not closed because there is opening here for this carbon and there is opening for this carbon as well. Are we together? Something can add to this, something can also add to this, which is carbon. But here, nothing can add. It has been closed. Are we together? In this case, we now draw the alicyclic hydrocarbon, which is we have carbon number 1 here, carbon 2, 3. We now said it is closed here. Now, this carbon itself, it's surrounded by what? By 2 bonds. We now add these 2 hydrogen to it. Make it what? Make it 4. That's why we said the bond that must surround the carbon must be how many? Must be 4. 1, 2, 3, 4. Are we together? Here as well. 1, 2, 3, 4. Here as well. 1, 2. Complete. Now, we now said how many carbon? We have 3 carbon. How many? We have 6 hydrogen. Are we together? From
Yes, sir.
Is it clear, my sister?
Yes, sir. Thank you, sir.
So we have C3H6. I understand what you're asking. I understand that, and I'm going there. Don't worry. So, and it is carbon to carbon single bond. It belongs to alkane family. It belongs to what? Alkane family. And if you have anything in forms of ring here, we start with cyclo, which is cyclo. So far, the carbon is 3. It is pro. The fact that it is carbon to carbon single bond, it is ane. That's why we call it what? Cyclopropane. If it is normal propane is C3. Put together. It is quite different from C3H6. This is propane, normal propane. Why this one is cyclopropane? Is that
So why
clear?
is it cyclo? It's not clear. Why is it cyclo?
Why is it cyclo?
Yeah.
Because it is in forms of rings. It is in
Okay,
rings.
this one. Okay, this one. Yes.
And we call it alicyclic.
Okay,
we
we now
together?
derive that cyclo from alicyclic.
Yes.
Oh.
That's why it is cyclopropane. Now, when you check this C3H6, when you check your alkane family, alkane, what do we have C3H6 in alkane?
No, sir.
Are you sure? Alkane family.
We have. That's propane.
That's what?
Propane.
That's what?
Propane.
Propane.
Yes.
So
That's it.
in organic chemistry, cyclopropane and propane, they have the same carbon atoms and the same hydrogen atoms, right? In such case, they call it they now said cyclopropane and propane, they are of the same isomass. They are of the same what? Isomass. You are still going there. Because they have the same numbers of carbon and the same numbers of hydrogen. They belong to the same what? Isomass. But how do you draw it? It's slightly different. Are we together?
Yes, sir.
So
Yes, sir.
cyclopropane and propane. So in that case. So another thing that we have for alicyclic is this. You also have something like this, like triangle or square. You know, they are closed, right? These carbon atoms are closed, right?
Yes,
Are they
sir.
not closed?
Yes, sir.
Yes, sir.
So in this case, if you want to write it, we have this carbon is surrounded by how many bonds?
2.
We have
We
one
have
remain
one
two
remaining two
hydrogen.
hydrogen.
Yes.
This one also
This one
remains two
also remains
hydrogen.
2 hydrogen.
These two hydrogen. These two hydrogen. Right?
Yes, sir.
Who can tell me the name for this compound?
Cyclobutane.
Cyclobutane. Thank you very much.
Thank you very much.
Do you know how it is cyclobutane?
Yes, sir.
Any questions so far? No question, right?
Yes, sir.
This is cyclobutane. When you count the total numbers of carbon, the carbon is what? 4. And hydrogen
And
is what?
hydrogen is what?
And the hydrogen is 8.
Do we have
Do we
anything like this in
have anything like
alkene?
this in alkene?
Yes, sir.
Yes.
Butene.
What's the name?
What's the name?
Butene.
Butene.
Butane.
So it means
So
that
it means that
cyclobutane or
cyclobutane or
cycloalkane,
cycloalkane,
they are the same
they
thing
are the same thing
as
as
alkene
alkane
family.
family.
Are we together?
Are we together?
Yes, sir.
In that case, we call
Sir, you
them,
wrote cyclo.
they
Is
have the
it
same
cyclobutene or butane?
butane.
See for each it.
Any question?
No, sir.
You don't have any question? So do you all understand what we've been doing so far? So far there is no question. So
Next
No one
question.
has
Next
question.
question.
someone has a question.
Yes, sir.
Okay, what's the question, please?
You know, under this alicyclic compound,
Yes.
we have cyclopropane, but can we also have cyclopropene that is be under 18?
Yes, exactly.
But we have 2 bonds, right?
In our next class, we are going to continue.
Yes, sir.
Okay. Any other question? Okay, so far there is no question. Let's call it a day. Thank you so much.
جزاكم الله خيرا.